Okay, you guys, this is your surface and lateral area of pyramids. I think if any of the lessons are tricky, sadly, I would say this might be one of your trickier ones. So let's just kind of get right into it. So the pyramid, the bases I could give you guys, because we should all remember what a pyramid is. There's one base, and then it all connects to the top. Just so you're aware, here are the bases I can give you. I can give you a square, so a regular, right? Because a square has all the same sides. I could give it to you as a rectangular. Now I'm going to star this one because you cannot use the formula for that. So I'll just write no formula. And we're going to do an example so you guys see what I'm talking about. I can do a triangle. So if it's regular, it's equilateral. I can do a hexagon, and I can do pentagon. Those are the ones you're going to basically see me use. Okay, and we all know the faces are the triangles. Isosceles triangles are our lateral face. Okay, so I'm just going to draw one just to show you obviously what it looks like and then kind of get through some of the little concepts that we really need to be aware of. So I'm going to draw just a square pyramid. So you draw that and then just draw a dot and connect everybody to the top. And there is your pyramid. So some things that we really got to keep in mind in a pyramid. So the bottom is called my base. So obviously this is your base. This is your base edge. God, I don't know what I was writing. You should know that this right here, this is called your lateral edge, right? Then we have this right here, which is on the lateral face. That is our slant height. Again, one of the triangles is your lateral face. And then something else that's really important when I go straight down inside it, maybe I'll just put that in a different color right here. This is our altitude. I know my hand's in the way. So you have your altitude. The other thing I need you guys to make sure you guys are aware of is if we take the altitude and we go directly across, so the middle. So we're going to the middle of one of the sides. This is our, hopefully you remember, our apothem. That marker's not working. Pen's not working. So that's our apothem. So those concepts are we still have to apply them. Okay. Let's take a look at our formula. We'll just get right into it just to do a couple of problems. So here's your formula for your lateral area. And I'm going to put a big star here again. This only works with regular polygons. So the formula, as I told you, does not work for the rectangle. We have to actually calculate it. So your lateral area is 1/2. Stop. 1/2 P times L. P is our perimeter of the base, and L stands for our slant height. So we still need those things. Okay, and then our surface area. Surface area, here we go again, is our lateral area, right? Plus, what's the only other thing we need? And yes, base. But I'm going to B, and then I'll put a star. Remember, B stands for the base, but it has to be the area. So you still need to calculate the area of the base of the polygon. Okay, so those are your formulas. And those are your concepts. You have to make sure you guys know all of these things. And we'll start the problem. Okay, so let's take a look at number 1. Okay, so it says the pyramid has, here's the problem. So since it's a rectangular base, make a star in your paper. No formula. So if that's the case, then we can't use the formula for this one. We have to break it up. So let's break this up. So what are the things that we're covering? We're covering the rectangular base. So I'll just put rectangles, obviously one rectangle. And then, hopefully this makes sense. Look, this front triangle is a six-sided, the base is 6. And this side is 2. So your front triangle and the side triangles are not equal. So I'm going to say plus 2 triangles. And we'll say front and back triangles because they're the same. Plus, I forgot the word, number 2. 2 triangles, we'll say left and right because they're the same. All right, so here we go. Let's start calculating. So the base, we have 6. I'll write it out in case you guys aren't sure. Times 2. So my base is 12. All right, so what I'm going to do with the front ones, I'm just going to highlight. For my eyes, I see this as my front one. So I'll just highlight that in yellow. So that's your front. Now, the height, because we all know obviously it's base times height. The height of this triangle is the slant height. So I'm going to take out that triangle so you guys can see it. Because again, I want to figure out that area, which is 1/2 base times height. The height is the slant height. So if this is 6 and this is 9, I'm going to find me that. That's the height I'm looking for. Okay, so we all know since it's isosceles, it divides it into 2. We have 3, we have 9. Let's do Pythagorean theorem. Put an x there. Plus x squared equals 9 squared. When you do Pythagorean theorem, we're going to get the square root of 72 for x. Okay, it wants this to the nearest 10th, so you don't have to simplify the radical. I'll work with it at the end. So this is my height. So then for this guy, it would be base times height divided by 2. So we have 6 times rad 2. 6 times rad 72 divided by 2 gives me 3 rad 72. I don't have my calculator. 1 second, let me get the calculator. Oh, it's here all the time. Okay, give me 1 second. So let me just make sure I do my minus. Yeah. So again, if you're not sure where these numbers are coming from, I'm doing 1/2. Oh, actually, let me double check that. It's 1/2. You have 6 times r rad 72, right? So you get 3 rad 72. Oh my God. But don't forget, we want 2 of them. So far I have 12 plus 6 rad 72. Again, because it wants the nearest 10th, I'll put it in the calculator at the end. Now let's do the left and the right triangles. So here's this. This is 2. Here's 9 again. I'm going to draw my right angle, my altitude. 1, 1. And now I'll just put a y there. Pythagorean theorem. So we got our 1 squared, y squared. So we get the square root of 80. Okay, so here we go again. We have 1/2 base of 2 times a height of 80. So then that gets us rad 80, but we need to times it by 2. So we have 2 times rad 80 gives us 2 rad 80. Put this all in your calculator. Again, because I did not ask you for this nearest, in radical form or exact. When you put all that in your calculator, you get 80.8 feet squared. Okay, so all I did for that one is just break it all up into different pieces, obviously, because it's regular, not regular. So I calculated all the different surfaces, I guess you can say. So here's that one, and here's that. Okay, so now let's go on to doing some regulars. All right, so this one's hard just because it's hard to draw. So you want a regular triangular period, which means equilateral. So here is my, we'll say, equilateral base, and everybody connects up. But have an idea visually just of what it looks like, and then let's just do the formula. So it says if each edge of the base is 10, so all of these are 10. Now the lateral edge. The hardest thing with this unit is knowing where to place things, and that's where I've found kids make mistakes. You guys sometimes make mistakes. You have to read carefully. This right here is your lateral edge. That's why it's very important to read carefully and put the numbers in the correct spot. Okay, let's write our formula. Surface area, 1/2 PL plus, well, since we know that this is the area of the base, let's replace the area of the base with a formula. If it's equilateral, make your life easy. You just learned this. The formula for equilateral is side squared rad 3 over 4. And it wants, we're going to say the exact. Okay? So let's put in the numbers that we know. So we have 1/2. The perimeter, well, that's an easy one. The perimeter is 30. Slant height, I don't know. So what I'm going to do with you guys, I'm just going to like highlight the values that we don't know, and we'll have to figure that out. I like to put everything in and then kind of come back to it. And then because you know the formula for your base, you don't have to really do much. So I have 10 squared rad 3 over 4. So when I calculate that, I know this is 25 rad 3. The question just is right now is what is your slant height? Okay, so let's see how to find slant height. So here's what I'd recommend doing is redrawing your picture. So I have one of the faces looking at me. So we're going to say this is one of your faces. So we all know that this piece right here, which is the base. So again, I'm going to write lateral face so you know what I'm talking about. It's not the base. This is your edge. So this is 10. This right here was your lateral edge of 8. Watch how easy this one is. I am going to draw that. That is my slant height. And because it's an isosceles triangle, and we all know it bisects it, if this is 5, you guys will do Pythagorean theorem. So we have 5 squared plus x squared equals 8 squared. And you're going to get that value to be the square root of 39. So that is what that is, which is what this is. So again, just so you understand, this is my lateral face that I took out, and I just found pretty much the height, which is your slant height, of the lateral face. And then when I calculate this, I'm going to do half of 30, which is just 15. So 15 rad 39 plus 25 rad 3. Done. Okay? All right. Let's take a look at the next one, a little bit of an easier one, thankfully. So we want a square pyramid. Okay, so I'm going to draw a square. Try to give you one of each so you have your example. Yikes, that was terrible. Okay, so there's your square pyramid. Let's put the values. So you gotta make sure you're putting them in the right spot. We have a base edge of 12. Here is my base edge. And now when it says the altitude of the pyramid, we talked about this. This is your altitude, and altitude is 13. So you have to make sure you guys are putting that values in. So since it's regular, I can use my formula, 1/2 PL plus, okay, my base is a square, so let's just do S squared. Let's put our numbers in first. I again, told you to do that just to get it out of the way. So we got 1/2. Perimeter is super easy, 12 times 4. So we got our 48. Here we go again. I don't know your slant height, so we're gonna have to calculate that. Plus side squared, so we have 144. You know what? I'll just go like this just in case you guys are at all lost, just so you guys see the numbers. Okay, so this one's different than that one, which is why I told you I'm doing all of these problems. That can be a little bit of a longer lesson, unfortunately. So in this one, just so you guys understand, I gave you the lateral edge to be 8. And all matters where you guys are placing the correct values, and it's really important. And again, this is where people made mistakes last year. This one has the altitude. So watch what you're going to do when I have the altitude. I'll do it in a different color. you're going to draw this, which again is my apithumb. I'm just drawing it to one side, it's easier to see it. Here, that is my slant height. I'm just gonna write SH, slant height. Okay, so that is my slant height, and all I did was draw this, which hopefully you guys remember, is your apithumb. All right, so the nice thing about this, well, no, I don't want to do that because I don't want to confuse you guys. So here, ready? I'm going to draw your square. If the side is 12, I'm going to find your apithumb. If the side is 12, each of these are 6. So here is my 90, okay? And then you guys should do your 360 divided by 4, which is 90, divided by 2. So this is 45 and this is 45. So that means my apithumb is 6. Apithumb 6. So this is 6. And then this is what we're going to be using to find our slant height. So we're going to do Pythagorean theorem again. So we have 6 squared plus 13 squared equals my x squared, which is my slant height. Okay, so we do the algebra. And we get x equals the square root of 205. We're going to round to the nearest, I'm going to say 100th for this one. I'll just put it right here. Make sure you guys are okay with your rounding. Okay, so now I'm just going to take that value, which is my slant height, and I'm going to put it right here. So we got radical 205. Then, because it says the nearest 100th, I'm going to put it all in the calculator, exactly what you guys see. And we're going to get 487.63 inches squared. So, again, you have to make sure you guys understand where the different numbers go. And then it's just a matter of kind of calculating it. This is a big understanding lesson, because you have to be able to see the different things. Let's do another few so you guys can kind of work your way around with understanding where their values go. All right, so let's do our next one. If I go a little quick, it's because some of the numbers you should be okay with. Regular hexagon. All right, so we have our hexagon. Okay, so there's your hexagon. It's regular, so I'm going to write my formula right away. 1/2 PL plus, all right, my base. So if your base is a hexagon, the formula for area of a hexagon you're supposed to remember is 1/2 apithumb perimeter. So please don't lose that. All right, let's put our values in and see what we can do from here. Altitude, 8. Here is your altitude. A base edge. Here is a base edge. Obviously, they're all the same. I just put it there, and you'll see. All right, let's put in the numbers we know. 1/2, we know our perimeter. 6 times 6 is 36. I do not know my slant height again. Plus, we have 1/2. I do not also know my apithumb. But I know the perimeter, again, of the base is 36. All right. So I say it's really easy, a lot easier to find perhaps that apithumb than maybe the other stuff. So let's take a look. If you remember how to do it, if you memorized it, you can do that. So I'm going to take my hexagon. I know this is 6. I'm going to take my apithumb, which is what I want to try to find, and do what we normally do. It bisects it, so I have 3's. Okay, we should remember 360 divided by 6 is 60, divided by 2 is our 30. And here's our 6. So if this is 3, here is our apithumb, 3 round 3. Great. So now the only other thing I need to find is my slant height. Okay, so here, this is how I want you guys to do your slant height. Your slant height is obviously the height of the face. If I give you the lateral edge, I would say you guys have it really easy, because you can obviously just take this triangle and you have a base and you have the, a side, and you can find this face, which is the slant height. If you don't, it's harder. You're going to want to set up your triangle like this. Okay? So let me redraw that triangle so you guys can see it. So what I have here is the triangle I just took out. You should know that this is 8. This right here, so this is where people make mistakes. This is I'm putting an A there, your apothem, which you just found me to be 3 rad 3, and this is my slant height. So that is where some people struggle with drawing. I would say they draw it to the wrong spot again. But they are very consistent. Just keep doing them. So this is what we're looking for. All right, so now I can just do Pythagorean theorem. 8 squared plus 3 rad 3 squared equals x squared, and here is my x. All right, so I have 64 plus 27. And then I get 91, so x equals the square root of 91. Let's put that right here. So again, I know these are a little bit harder. And let's find our answer to the nearest 10. So again, we're going to put that whole thing in the calculator. And you get 265.2, we'll say units squared. So I need to see all this work. These problems are definitely one of the hardest ones, I think, of surface area. Okay, let's go to the next one. So we're doing a regular hexagon again, but you're going to see how I'm going to change what measurement I give you and how that changes the problem. So I know this might be long, but I'm trying to give you guys every scenario. Surface area, it's regular. Base, again, is a hexagon. All right, so let's put our numbers in. So this time, again, we have an altitude of 6. So here is your altitude. Now, difference. Lateral edge, this was base edge. Please understand the difference. Lateral edge of 10. Okay, so do you guys have anything? The answer is nope. So we have to find everything. We got to find P, L, A, and then obviously P again. Okay, so watch how you guys are going to do this one. Again, when I give you slant height, when I give you altitude, maybe write this down, and you want slant height, you're going to use your apothem. Okay, as you saw from there. Now in this one, when I give you altitude, and I'm giving you lateral edge, you are going to use this, which is, if you remember, the radius of the polygon. I would definitely recommend you writing that down. So you're trying to find this, which is pretty simple for us because we know this is a right triangle. We can use our triple. So 6, 8, and 10. So that should be okay. And then, now let's draw our hexagon. So we know this is 8. We can go like this. Okay, remember what goes on top? 30, 60. So if this is 2, then we know that this guy is our 4. So if that's 4, that's 4. So you know a side is 8. And I know my apothem is 4 rad 3. All right, apothem 4 rad 3. You just took your whole lesson on that. If a side is 8, 8 times 6, perimeter 48. Perimeter 48. Yes, we're almost done. Slant heights. Okay, so I told you, if you are given your lateral edge, what you guys can do for the slant heights. You have 2 options. You can just use the face, knowing that this is 8. Lost train of thought. And knowing that this piece right here is 10. Sorry, this actually is not 8. Let's try that again. Oh no, it is 8. Sorry, I was bisecting it. And these are 10. What you guys can do is find me the slant height like this. So this would be 4. And we can do 4 squared plus x squared equals 10 squared. Or, and again, I'll just write you guys a note. This is to find your slant height. Or you could still use your picture, and I can use altitude. If you're going to do slant heights, remember you need your apothem. And in that case, should go like this. I would be using 6, and my apithum was 4 rad 3. So either one will find you guys your slant height, and you guys should get x equals radical 84. So I don't care how you guys do it. Make sure you understand the problem. Put rad 84 here, and we're going to calculate to the nearest hundredth. So you're going to probably want to stare at this problem a few. Especially for this. This is how you guys are finding me the slant height. This would be your hard one, because first you have to find me so many pieces of information. Again, you can either use the face, or you guys can still use your altitude, your slant height with your apithum here. So keep this in the back of your mind. This one's definitely a hard one. All right, so going on to 25, pentagon. 5. All right, the minute you guys see pentagon, you're gonna remember this trig. Because remember, if you're gonna calculate your apithum, you're gonna have to use trig. Okay, I made this one a little easier because the fact that trig is involved, it's obviously gonna be harder to begin with. So we have 1/2 PL plus base, again, 1/2 AP. Put our numbers in. We have now still a height. Height is here of 15. Slant height. I gave you guys the slant heights. Slant height is 17. All right, let's put the pieces we know. 1/2. Oops. 1/2. I do not know P, and I do not know A or P. So all I know is slant height. Slant height is 17. Gotta find the perimeter. Gotta find this, gotta find that. Okay. So watch, this one's not terrible for us, because when I take my altitude and my slant height and I connect it, this is my apithum. And it makes my life pretty simple, because that's again a triple. If you don't know the triple, do Pythagorean theorem. Here's your right angle. But you should know the triple, which is 8. So apithum is my 8. Great, let's put that in. Okay, so I'm going to take that hexagon out, and we're going to work our way around to find me the perimeter. Okay, so here is your apithum of 8. Here's you guys having to do that right triangle again. Here's where I told you your trig is involved. So if you remember, 360 divided by 5, 72 divided by 2 is 36. All right, so I want to find me that. Okay. So opposite adjacent, you're going to be doing tan 36 equals opposite over adjacent. Now, once you find that, that's only half a side. You're going to take that value, which I'll do it just so we're on the same track. 8 times tan 36, I get 5.8, times that by 2. So times by 2, and just so you guys know, a side is about 11.624 ... Now I want to times it by 5 so we can find our perimeter. So times by 5, and I get about 58.123 ... But remember, because this is not my final answer, you do not want to round. So just continue to keep using that calculator. Times it by 8, times it by 1/2 plus 17, and then you gotta see if you guys can get the number in again. And and you're gonna round to the nearest tenth. Units squared. Okay, so just be aware you're gonna have to do trig on that one anytime it's a pentagon. Okay, just almost done. All right, so we definitely need to take a look at this one. I might save this one, but you need this. Okay, so here we're talking about the frustum again. The frustum can happen in a cone and a pyramid. So the best way, I'm going to draw it in pencil in case I want to draw it again. It's a right pyramid whose base is, they're squares. Okay. So I'm going to draw a square base. You can mark them all. And then what you need to do is sometimes, I don't know, these are not that good with. Draw another square base. Remember, because your pyramid got cut off. That's what your frustum is. Let's see. You know what? I think I drew this one as just a regular square. Let's try. And then connect. 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 That's the best we can. And this is also the same. So remember, your frustum is a pyramid, right, that has been cut off. And so that's only what you're trying to find is what's left over. Okay, so it's the exact same thing that we did with the cone. Let's put these numbers in. So it says these sides are 19 and this is 9. The height of the monument is 12. So that means I'm just going to put that here. It's 12. Find the surface area. Okay, so I want you to recall what we did for the cone. Cone? Yeah. Cone? Yeah. So what we want to first find is the surface area of the big pyramid, total, right? Minus the top, so that's the surface area of, let's say, the top pyramid. And let me change that, don't write that down. We don't want the surface area, remember, because the surface area includes the bottom, and we don't want to include the bottom. We want to get rid of just your lateral area. And then we want to add back the base, and in this case, our base is a square. Okay, so let's put these values or the formula down so you guys can see it. Okay, so again, I know this one's hard. Hopefully it makes somewhat of sense. It's just like our cone. And if you think about this, if I extend it, it's just going to look, I really want to extend it, but if you kind of can see, that's really what it looks like, and I cut that top part off. So hopefully that makes more sense. So we want the surface area of the big. So we have 1/2 PL plus my base, which is a square, minus just the lateral, plus back the top base. So top side squared. Okay, I'm just gonna do one of these, hopefully you guys get it. All right, so let's put the numbers in that we know. We have 1/2. The perimeter is the perimeter of the bottom. Well, that's easy. It's 19 times 4. So that's gonna be our 76. I don't know my slant height, I'm gonna find it in a minute. Plus 19 squared, so I'll put the 19 here, is 361. Minus, we have 1/2. The perimeter is the perimeter of the top, so 9 times 4, which is 36. Don't know slant height again, plus, now I want to add back that, because I want to wrap the top. So we're going to add back the area of this, so 9 squared, which is 81. I'll put the 9 there so you guys are realizing. So we are trying to find, again, our slant height. Okay. So if you recall, how do we do this? Well, if you remember what we did last time when we were doing the cone, first of all, this is our slant height. Hopefully it's coming back to the teeniest bit. You're supposed to have done the proportion, right? Where you guys would do the whole thing. So the only problem with that is we need to find radius, in a way, radius. But in this case, it's called your apothem. And then obviously you have to find the slant height because you got to find of everything. Now, watch how this one works. This is a little harder. First of all, if this is 19, remember what we did for the square. This is half, so it's 9.5. Okay. Okay, sorry, I was thinking. And then if this is 9, then this is 4.5. So here's how you guys, if you remember, I'm trying to find my slant height. Watch. Okay, so if this is 9, I'm sorry, if this is, okay, so this is 12. This whole thing is 9.5, but this is like right here. I'll probably highlight it. So this 4.5 is this 4.5 right there. If I actually drew it a little bit better, let's kind of show you that a little bit better. Let's extend this up. So those 4.5s are the same value. So if that's the case and you have 9.5 total and you have 4.5 up here, this is like that trapezoid if you guys remember. So this is 4.5, which means this piece right here is 5. Then, if you guys look, you have your triangle. You have 4.5. I'm sorry. You have 5, 12. You hopefully should remember the triple. 13. So this is 13. Okay, I know this is actually kind of sloppy. It's really hard to do this one. All right, now we're ready to find your slant height for this. This is what X is. Okay, so here comes your proportion. So ready? Hopefully this looks somewhat familiar now. X over the 4.5 equals X plus 13 over 9.5. You might just have to stare at it a few times to kind of get the idea of what to do. But again, you've done this before. You know, you bring down this. This is 12. If this is 4.5, this is 4.5. The whole thing was 9.5. So this is your 5. Here's your 13. And then this is what we did when we were doing the cone. So just double check that. Okay, and when you cross multiply, you should get X equals 11.7. So that means this value is 11.7. That's really important. That was the number we were kind of looking for, because now we can substitute it in. The slant height is the slant height of the whole cone, which is whole pyramid. 11.7 plus my 13, so 24.7. And then the slant height of the top, we already know, is 11.7. Okay, yes, I told you these are your harder problems. And then let's go to the nearest integer. Integer is just the whole number, so put it all in your calculator. And here is your final answer. Okay, so you're definitely going to want to look these over maybe a few times just to have an understanding of kind of what to do. Okay, hopefully that makes sense. It's kind of I mean, you're gonna have something like this for homework. Just make sure you remember that you just don't want to, include the double top. You'd be doing lateral area here, and then depending on which one you make your base, you're not including another 12. Like maybe find the surface area of the prism and then minus 12 by, I guess 12. Minus one of the 12 by 12s. So you can get rid of that. Okay? Because I don't want to take any more of your time. So hopefully this should be okay for you guys. Okay? All right, you guys try the best you can. I know this is your hard unit, so I should expect some questions from you all. If you decide to do number 7 and you want the answer, just let me know, but you have something like that similar in your homework. Just take your time, talk yourself through it, have the understanding. Always draw your pictures. Understand, again, the biggest thing would be making sure you know which triangles to use. If I have the altitude slant height, use your apothem. If you have an altitude and a lateral edge, you want it the radius. Okay, so again, use your notes and try the best you can. All right, you guys, bye.